Hello everyone, this is section 8.3 and 8.4. Basically, I'll combine two sections, which is about exponential functions. All right. So exponential function is, let's say f of x is equals to b to the power x. All right. So if we see a function in this form, we say it's exponential function, but there are conditions. Let's say this b and the base must be a positive number. All right, so if we say b is greater than 0, we say it's a positive. And also b is not equals to 1. So if we have this condition, then we can say it is an exponential function. All right, so that means, let's see, if we have f of x is equals to 2 to the power x, then yes, this is an exponential function, because now in this case the b we have here is b is 2. So this 2 is greater than 0 and it is not equals to 1, right? So this is an exponential function. One half to the power x. So is this an exponential function or not? It is, right? Because still this one right here, the base is this whole thing 1 over 2, right? So it is still greater than 0 and it is not equals to 1. So this is also an exponential function. All right. Similarly, let's say f of x is equals to 1 to the power x, then this is not exponential function, because the base we have here is 1, right? So this is not an exponential function. F of x is equals to negative 2 to the power x. So this is also, so this is not exponential function. This is also not an exponential function, because we have negative number at the base. As we said that b must be positive. All right. So this is how we can see whether a function is an exponential function or not. Okay. Now let's see the graph of an exponential function. So the graph of an exponential function is always like this. That goes through this point, is always, this point right here is always 0, 1. All right, so this is always like this, and this is b to the power x when b is greater than 1. All right. And also there is another types of graph which is again like this, always like this, that goes through 0, 2. So basically this one right here is never gonna touch this x-axis, and also this one is never gonna touch x-axis. It will approach to x-axis, but it is never gonna touch x-axis. All right, so this graph right here is when we have b greater than 1, and this another graph is when we have, it is still the graph of b to the power x when b is greater than 0 but less than 1. All right. Okay, so this is how the graph is going to look like. So this is always like this. The shape of the graph is always going to look like this. So let's say if we want to graph f of x is equals to, let's say, 10 to the power x. All right. So if you want to see the graph of this, it's always, like I said, it's always, as this is, since this is greater than 1, right? So I said here, if b is greater than 1, the graph is like that, which is increasing, right? So it is increasing like this, and this one goes through 0, 1 always, right? And if we have f of x is equals to, now if the base is now less than 1, let's say 2/3 to the power x, then the graph is, so this is f xy, and the graph is, in this case now it's decreasing, right? And this is 0, 1. So this is the shape of the graph is always like this, all right? Now let's look at let's see what is there in this chapter. Okay, so now let's see let's see, okay, so now let's see solve. All right, now let's deal with an exponential function and solve, which is something like this. Okay, so now to solve something like this, well, we know that if we have, let's say m to the power a is equals to m to the power b. So if these two are equal with the same base, then we can say the power is also same, or power must be equal. A is equals to b. All right. So the idea here is, since here we have 2 on the base, right? So what we want to do from this right hand side is that we want to change this to a base 2. So on left hand side we still have 2 to the power x, on right hand side 16 we can say 2 to the power 4. So this way we have same base on both sides, right? And these two are equal. So that means the x is 4. Like I said here, the power must be same, so here power must be equal. So there you go. So we are trying to solve, we use solve. So whenever you see solve, that means we're trying to find the value of x or any variable of that equation. So we found the value of the variable, right? Okay, let's solve. Let's solve like this one. All right, so now here 16 is in the bottom. All right, so what we have to do here first is 1/16 is also same as 1/4 to the power 2, right? So, but the idea is we have to make the base same. But here, this 4 is in the bottom, so we have to move this to the top. So whenever we move anything from the bottom to the top, then the power is going to be negative, since there is a positive here. So that positive will be negative if you move that to the top. So here, so from here, what we can say from here is that 1/16 is 4 to the power -2. All right. So again, now we have same base, right? Same base on both sides. Now for this, we can say the power is also same. So x is equals to -2. All right. So this is how we solve a equation like this. Okay. Now let's go to thing called logarithmic function. All right, so logarithmic function, we always write logarithmic function like this. All right, so we are introducing the thing called log, all right, with the base, whatever the base is, b, let's say b, and again the b must be uh, greater than 0, and b cannot be 1. All right, same conditions like it was on the exponential function. And the graph of this one is also, it has a standard graph. So now in this case, the graph is like this, that goes through. Now this point is now 1 comma 0. All right, graph is always like that, and this will be if b is greater than 1, so it will always look like this, and this is x-axis, this is y-axis, and this graph is approaching y-axis but never gonna touch y-axis. And another one is like that, and this one is if b is greater than 0 and less than 1. All right, so graph is always like this, the shape of the graph. Okay, now what we're going to learn now is we need to, let's say, let me just write it opposite way. So this is an exponential function, right? Because we have a number on the base and a variable on the power, right? So this is an exponential function. Now we need to change this exponential function, because this is an exponential function. All right. We just say exp. Now to change this to a log function, a logarithmic function. All right. So the idea here to change an exponential function to a log function is, all right, so idea is whatever we have on the power, so in this case we have x, right? So whatever is there on the power, x equals to, now since we're changing it to a log, so we have to introduce log, and the base, the bottom number is always the base of this exponential, which is 5. So 5 of, and we have y, so y. All right, this is always how you find or how you change from an exponential function to a log function. All right, it doesn't, so let's say something like this. So it doesn't matter what we have on the power. So it's always whatever in the power. So in this case, we have this whole thing y minus 1. So y minus 1 is equals to, now we're going to introduce log base 3. Let me just write that again. 3 of x. All right, so this is how you find or how you change from an exponential function to a log function. Now from log to an exponential, so now if log is given, so log is given, we need to change this to an exponential function. So again, the idea is this base is gonna move here to the base of an exponential function. So on the left hand side, this log will be gone, so we're just gonna have x is equals to, on right hand side, this base 3 is gonna move to the base of an exponential function 3, and the y is is going to move to the power. All right, so this is the idea. Let's say log base a of y plus 1 is equals to x. So this one, again, like I said, this a on the base is going to move to the base of an exponential function. So on left hand side, we're just going to have y plus 1 is equals to, now this a is going to be the base of an exponential function, and this x is going to move to the power. All right, so remember this process. All right, this is very important later on when we start solving. All right, so you need to know these ideas to solve those kind of equations. All right, so that's it for this one. I'll see you in the next video. Thank you.